Morning, guys. Another Monday. Hopefully, our last one online. Okay, so we'll have a look at the homework from Friday's class. So, a solid metal sphere of radius 18 centimeters is melted down and remolded into a solid cylinder of radius 36 centimeters. Okay, the diagram is not to scale. Find A, the volume of the sphere. Okay, so part A, we're trying to get the volume of the sphere. So we go into our table book and we get the volume of the sphere formula. I know I used it, so here it is here. Okay, so there's my volume of a sphere formula. What do I know about the sphere? So the volume is pi, no it's not. It's 4 over 3 pi 18 cubed. Yeah? So they wanted in terms of pi. So that is 7,776 pi centimeters cubed. Okay, and then they wanted to find the height of the cylinder, which they haven't given us. So this is where, like the example I did, where we take into account the fact that they're recasting the sphere as a cylinder. Okay, so the volume of the sphere, which is 4 over 3 pi or cubed, is equal to the volume of the cylinder, which is pi or squared h. So whatever it's made of, metal, no metal is lost. So whatever metal was in the sphere is going to be recast now in the shape of a cylinder. Okay, and no metal is lost, so the volume of the sphere is equal to the volume of the cylinder. Okay, now this I've already done. It's here. So you don't need to do it again. I can just replace that with 7,776 pi. Now the cylinder. So pi is pi. Do I know the radius? I do. It's 36. So 36 squared. And the height, I don't know. That's what I'm trying to figure out. Okay, so I'm going to do this. Just kind of get the easy maths out of the way. So 1296 pi h. Now, we're trying to find the height. So this is what I'm trying to find. So I need to divide by 1296 to cancel the 1296. And I need to divide by pi to cancel the pi. But if I do that on the right, I have to do that on the left. So 1296 and pi. The pi's on this side will cancel as well, leaving me with 7776 divided by 1296, which is 6. So the height of the cylinder is 6 centimeters. Okay, and then question 8. A rectangular block of metal of volume 1344 centimeters cubed is melted down into 2 identical metal spheres. 10% of the volume was lost in the melting. Okay, so hang on. So the rectangular block is 1344 centimeters cubed. Okay, that's going to be turned into 2 spheres, but 10% of the volume is lost. So we have 2 by spheres, right, but it's going to be 10% less than that. So I'm going to need to do that calculation. So 10% of 1344 is 134.4. So that means the 2 spheres, 1344 minus 134.4, the 2 spheres have a volume of 1209.6 centimeters cubed. Okay, this is how much was lost in the making of the 2 spheres. Yeah? Okay, so if 2 spheres is that and they're identical, that means 1 sphere, if I just divide that by 2, I get 604.8 centimeters cubed for 1 sphere. And, zoom out. Oh my God. The volume of a sphere is here. Okay, so I have 4 over 3 pi r cubed, which is the volume of a sphere, is 604.8. The question is find the radius, which means this is what I'm trying to find. Sorry. Hang on. Oh my God, it just will not zoom properly. Right, there we go. Okay, so I'm trying to find that r. So I'm going to divide by 4 over 3 to cancel the 4 over 3. And I'm going to divide by pi to cancel the pi, which means I need to do the same over on this side. So divide by 4 over 3 pi. Now there's no pi to cancel there, so I'm actually going to have to do that division. But that's fine. I have a calculator. So r cubed equals, so I'm doing 604.8 divided by 4 over 3 shift pi. Oh my God, I'm pressing all the wrong buttons. Shift pi. And that is giving me 144. Now this number goes on, okay, so 0.385, and it goes on. So I'm not going to, this is what we were talking about on Friday about rounding. I'm not going to write it all, but I'm going to keep it in my calculator, okay? So now I'm going to get the cubed root to get rid of the cube, and I'm going to get the cubed root of this number here. I have not removed any accuracy because I've kept the number. So in my calculator now, I am writing cubed root, so shift square root gives me a cubed root, and then I'm going to use the ANS, the answer button, okay? And that way I have not lost any decimal places. So that gives me 5.246, it goes on, well, I'll just write it, 154.274, yeah? And now the question says, you can actually just see it there. See it there, 2 decimal places. So that's 1, that's 2. And then we're going to stop. So we look at the next number. Is that going to be big enough to push the previous number? Yes, it is, because it's over 5. So that means the radius is 5.25 centimeters. All right. So that's your recast problems. The first of the kind of real higher level. They're all higher levels, just these ones keep appearing. So 22nd of March. Oh, sorry, Monday. Right. So let's go in and do the second of our higher level problems. Just flying past it there. Okay. So we've done the recast problems. We did that Friday. Today we're going to look at the flow problems. These ones can be a little tricky to wrap your head around. Hopefully, if I explain it well enough. Okay, so here we go. Flow problems, number 2. Okay, so problems involving the flow of liquid are usually based on the speed or the flow of liquid through a cylindrical pipe. The flow speed through the pipe equals the length of the column of water in the pipe in that particular moment. Okay, so if it says a flow speed of 12 centimeters per second in a pipe, that means, it's hard to do this now without showing you, I don't know, I feel like I need hand gestures for this one. But if you imagine that the pipe fills up to a height of 12 centimeters in a second, and then that water moves off and another 12 centimeters worth of water comes in the next second, and then that moves off and another 12 centimeters comes in. Okay, so when they give you the flow speed, like they say it flows at 14 centimeters per second, that means for a given second the height of the cylinder of water is 14. If it says 20 centimeters per second, then the height of the cylinder of water for a given second is 20. Okay, so it's basically how much of the pipe that the water can fill, and that's the whole trick to these questions. Okay, that the flow speed actually equals the height. Okay, and that's because it's how much of the container it takes up in a given second. Okay, so we'll look at a problem, okay, and I'll talk through it a bit more. So water is flowing through a cylindrical pipe at a speed of 35 centimeters per second, right? So we immediately the radius of the pipe is 5 centimeters, and the water is being poured into a cubic tank. Okay, so cubic. So that means it's a cube. Yeah, so if it's got a side 100, that means it's length 100, width 100, height 100, okay, because it's a cube. Find the rise in the depth of water in the tank in 5 minutes. Okay, so we need to work out the volume of water being delivered to the tank. Okay, the volume of water being delivered to the tank. It's been delivered there by the cylindrical pipe. Okay, so what we're going to do is we're going to work out the volume of water in the tank, in the pipe in 1 second. Okay, that's why we take the height to be 35 centimeters, because that's how much water is in there in 1 second. And then we'll figure out the time after that. Okay, so the volume of a cylinder, I should have it fairly handy, do I? Yeah, here it is. So that's the volume of, there you go. That's the volume of a cylinder. Okay, so pi, they want us to use 22/7. It says it over here. The radius of the pipe, there it is there. The radius of the pipe is 5 centimeters, and we have to square it. And then the height of the pipe, if we're dealing with 1 second, is 35 centimeters. Okay, it is basically going every second, it's going to fill up to a length of 35 centimeters, and that bit of water will move on and it'll fill up again to a length of 35 centimeters, and so on. Okay, so let's figure out what volume it's delivering. So 22/7 multiplied by 5 squared multiplied by 35. So it's 2750 centimeters cubed per second. Okay, so that's how much water is going through the pipe per second. Okay. So we need to figure out, find the rise in the depth of the water in the tank in 5 minutes. Okay, so if that's how much is going in a second, how much hang on. Love when it does this. Sorry. Okay, right. So 2,750 centimeters cubed is flowing through that pipe per second into the tank. We want to know how much is going to go into the tank in 5 minutes, because that's what we were asked. We were asked to find the rise in the depth of the water of the tank in 5 minutes. So how much water goes in the 5 minutes? Okay, so if I take 2,750 and multiply it by 60, okay, so remembering that this is per second. So if I multiply it by 60, 165,123, that's how much is flowing in per minute. So then if I multiply that by 5, 825,000 centimeters cubed in 5 minutes. That makes sense? Okay. So we know that the tank is 100, like obviously it's 100, 100, 100 because it's cubic, but we want to know how much it has filled up, okay? So we know that there is 825,123 centimeters cubed of water gone into this tank. And we want to know how much has that caused the water to rise. It's obviously not filled it, because 100 multiplied by 100 multiplied by 100, this tank holds 1,000,000 cm cubed of water. That's what it holds. And we're only at 825,000. So the tank is not full. Okay? So what we're trying to figure out is the height of water in the tank, not the height of the tank itself, because the tank itself is a cube. And we know it's 100 by 100 by 100. So what we do is we use the formula for the volume of a cube. So the volume of a cube is not in the formula in tables book, so I have this learnt off. So it's length by width by height. Now, I'm not looking for the entire cube, okay? I'm basically looking for the capacity or the volume of the water that's in it, okay? So how much has it filled up? So I know the volume. The volume is 825,000. I know the length is 100, the width is 100, and the height of the water is what I'm trying to figure out. Okay, this is what I'm trying to figure out. So I need to get rid of, so divide by 100 to get rid of that 100, and divide by 100 to get rid of that 100. Yeah, so then I need to do the same thing over here. I need to essentially divide by 100 twice. So 825,000 divided by 100 divided by 100. and it gives me a height of 82.5 centimeters. Okay, so there's space for it to go up to 100 centimeters in height. This has filled it to 82.5 centimeters in 5 minutes. So find the rise in the depth of the water in the tank in 5 minutes. It has increased by 82.5 centimeters. Okay, so that's your flow problems. It's complicated slightly because of the time element, okay? But I suppose the first thing you need to remember is that when they give you the flow speed, that's the number that you use for the height. And then just remember that that's only what's flowing through the tank in 1 second. So it fills to 35 centimeters in a second, another 35 centimeters in the next second. So that's where you get the time element from. Okay? I personally think these are the hardest of the 3 higher level ones. They're also the least asked, so I suppose that's positive. So play that back a few times. Let me know if you need any further clarity. I'm trying to explain it obviously as best I can without being in front of you. So hopefully I'm getting the idea across. But let me know if there's any issues, okay? So for homework, I saw okay, so there's 1, 13. I knew I saw 2. There you go. So there's 10. And 13, I think. Now the water is poured. What is the depth of the water after 1 minute to the nearest second alone take to completely fill the tank? Yeah, that's another flow problem. Okay, 13. Okay, so those 2 for Wednesday, please. Thanks, guys.